calculate the volume of the solid of revolution that is generated by revolving the region bounded by the curves y equals x and y equals negative x squared plus 5x about the x-axis. So I need to find that region that I'm revolving, and it will be helpful to know where those two curves intersect when I'm drawing them. So I'm going to start with that. Set negative x squared plus 5x equal to x and solve for x. So I get x squared minus 4x equals 0. So that happens when x is 0 and when x is 4. So I know they intersect at 0 and 4. So that will help me in the drawing of the two curves. So I know y equals x is just this diagonal line. And y equals negative x squared plus 5x. I know that's a parabola that opens down because of the negative leading coefficient. And I know its y-intercept is 0, because if you plug 0 in for x, you get 0 for y. So if the y-intercept is 0 and it's a parabola that opens down, it's got to look something like this. And it's going to intersect with y equals x at 0 and at 4. So I'm looking at this region between my two curves. But rather than just finding the area of that region like we did in the previous question, I'm going to take that region and rotate it about the x-axis. Okay, so to see what that looks like, to figure out what the volume is when you rotate that around the x-axis, I want to pick a random rectangle, a representative rectangle, and see what happens to that when I rotate it about the x-axis. So here's a little rectangular slice of the region. It's at a random spot x along the x-axis, and it's got a little thickness which we'll call delta x. We're going to rotate that rectangle around the x-axis. When you do that, you're going to sweep out a shape that looks like a washer. And it is helpful and required to draw a picture of what you get when you sweep out that rectangle. So this is a picture of my slice after I've rotated it around the x-axis. It looks like a washer, and it's got some thickness. I'm a terrible artist, but try to show what that thickness there, thickness of delta x. So if I want to find the volume of this washer, the volume of my slice, well, the area of a circle is pi r squared. So to find the volume of a circle, it would be pi r squared times the thickness delta x. So I could find the volume of the large circle, subtract the volume of the small circle, and I would have pi r squared delta x minus pi r squared delta x, where r is the big radius and little r is the little radius. All right, I'm going to factor out a pi and a delta x. And now I just have to figure out what big R and little r are and plug them in, and I've got the volume of a slice. So big R is the larger outer radius when you're rotating this purple rectangle about the x-axis. So my larger radius is the distance from the center, which is the x-axis, up to the blue curve, which is negative x squared plus 5x. So at a distance of x from the origin, the y value at the blue curve is negative x squared plus 5x. So that's my big R. So this is going to be pi times big R is negative x squared plus 5x. Okay, that's big R. We got to square it. And then little r is the distance from the center, which is the x-axis, what I'm rotating around, to the green curve, which is x. Okay, so that is the volume of a single slice. So what I want to do next is I want to add up a bunch of those slices at all different x values. x1, x2, x3, x4, a bunch of different xi values. So I'm going to add up a bunch of slices, a bunch of v sub I slices. So this is the sum of pi times negative x squared plus 5x squared minus x squared delta x, and these are xi's. Then I'm going to take the limit as n goes to infinity. So we'll have I goes from 1 to n. So the volume, my total volume, is the limit as n goes to infinity of the sum I wrote above of the VI's. So that's a Riemann sum, and it translates to an integral. So instead of xi's, they just become x's. So I've got pi times negative x squared plus 5x squared minus x squared. And instead of delta x, that becomes dx. So I have to evaluate that integral, and I'll have the volume of the region. And I have to go from 0 to 4. The region is bounded from x equals 0 to x equals 4. Okay, so I'm going to pull out the pi. I missed a set of parentheses here. There we go. Pull out the pi. So I have the integral from 0 to 4. I'm going to square the negative x squared plus 5x. So I get x to the 4th minus 10x cubed plus 25x squared minus x squared dx. This is pi times, I'm just going to take an antiderivative of x to the 4th, that's 1/5 x to the 5th, of x cubed, that's 10/4 x to the 4th, and then I have 25x squared minus x squared, that's 24x squared. So that becomes 24 over 3x cubed, which is 8x cubed. And evaluate that from 0 to 4. And you get pi times, plug in a 4, you get 76.8. Plug in a 0, you get 0. So this is 76.8 pi.